Okay, and we're live. All right, welcome back to the Shop Class Podcast. Tonight we got a special guest, former student, now a friend, colleague in a way, is Riley Flores. All right, and she is coming to us from Brown University.
Yep.
Okay, is that Rhode Island, right?
Yeah, Rhode Island.
Okay, and we also have in the house Duke. Duke is from East Stroudsburg, Pennsylvania, and he is a middle school teacher, shop class teacher, and he's got on the Hawaiian, the island customs concepts.
Yeah, we got it going on.
All right, we're gonna get into that, and then we got Matt Bloomquist. Bloomquist is from Taylorville, Illinois, and he's the one who builds houses from scratch with the students. No classroom, literally a job site. Thanks for joining, Matt. First things first is we're gonna talk to Riley in a second, but we gotta talk about the island customs. We had a guest on, Todd, and he's in Hawaii. Okay, so this is like a follow-up, right? And what he did was he joined us for the show, but he also personally does these beautiful tiki projects. And two of us went and bought it. I have mine right here. I didn't open it yet. Duke, you want to tell us about yours?
Yeah, so I was admiring his hat because I like to keep my head covered when I'm outside. So he's like, "Oh, you want a hat?" I'm like, "Yeah." So he hooked us up with a hat, and then he had a nice banner in the background. So I was like, "Man, the banner's cool. The kids like seeing the banners and everything." So I said, "Throw a banner in there," and same thing. He was talking about these little tikis that he made.
So cool.
And this is made out of monkey wood. He was saying monkey wood. And this is shiny. It's nice and solid. And he even threw in a couple stickers. So nice. A fellow guest we're supporting today on the Shop Class Podcast. So I got the banner. Island Concepts I'll put in my classroom. So I'm sure that'll be a discussion piece for the students. And then stickers. Kids like stickers. He threw in about 8 or 9 stickers as well.
All right.
It's just, something for the kids to get interested in. They'll look on their Instagram. Maybe they'll check out his. Some kids are into like these. He used a lot of the flake paint, so it might get kids interested in these different types of shiny paint.
This is straight from Hawaii. Oh, that is so cool. Right there. That goes on the back of my truck. All right. All right. Whoa. Dude, this is so cool. This is like legit cool. Wow. Look at that. It's like hand carved. That's so cool. And it's like glossy.
It is really, it's nice. There's a nice gloss on it. Yep.
Yeah.
It's a heavy like heft to it.
Yeah, it is a little, it is pretty heavy.
Yeah. Oh yeah.
It's almost like a piece of maple. Yeah, I just sent him a message on Instagram too. He said, "Tell everyone," he said, "Aloha."
And this is a great episode. This guy's a really like a passionate educator. He's kind of, he works for the paint company, but in a way, he's kind of like a teacher, It was pretty cool talking with him. Okay, I like it. Thank you, Todd. Very cool.
Todd, thank you.
Yes. It's so cool that he sent it all the way from Hawaii, That's awesome. All right, so Riley, the guest of the show. Let's get to it. Okay, Riley, we're going to ask you the same question that I ask all my guests is, did you have shop class growing up?
So, unfortunately, growing up, I never took the traditional shop classes, but I did get like a taste of like the whole design and innovation like concepts. And so like a lot of that had come in through like the different programs I was in growing up, some of which were like at NJIT, New Jersey Institute of Technology, where like I know each summer I was in a different program, and so they taught me about environmental engineering, mechanical, aeronautical, all these different types of things, and we always had like design projects. So there's always opportunities for us to for like hands-on activities, you know, different things like that.
Oh, so wait, while in high school you had that?
Yeah, so actually I had started that I want to say elementary school, and it went, I want to say, to sophomore year of high school. Yeah. And then yeah.
Oh, no kidding. I didn't know that. So you were doing stuff with NJIT in sophomore year of high school?
Yeah, all the way. I think we started 4th grade all the way to sophomore year of high school. That's when
Oh.
the whole like STEAM Academy and like engineering club came in as well.
Oh, wow, no kidding. I didn't know that. All right, that's interesting. And okay, so I have a picture of you here with from your Instagram with the robotics team. And let's see. And this is Mr. Fernandez, and he's here with like this is your whole crew right here.
Yeah, no, that was us. Like honestly, I think those are all the founding members. Yeah, because originally we started off as a robotics club, but remember Bark, I'm not sure if he's the science supervisor, came to us, and then like a few other teachers, and he's like, hey, let's make an engineering club like on top of the robotics club. And so like that's where we were there, and then we also had joined like the engineering club as well.
That's awesome.
Yeah, we were called breakers. Yeah.
Yeah, that's funny. So okay, so this is pretty cool. So you were on the robotics team, and you did some extracurricular activities throughout your high school career. And are you in touch with any of the people from this team still, or no?
Yeah, actually, well, not like too much, but yeah, Michael Sanchez, we will catch up every now and then during breaks. He's actually studying at Yale. I don't think he's doing like STEM anymore. I think he's pursuing I believe something in literary arts, but I'll keep in touch with him. I've actually seen a few other members at the SHIP convention. So SHIP stands for the Society of Hispanic Professional Engineers. And so I've seen a few of our members over there, and we'll chat and catch up at those conventions.
Ah, okay. That's this right here.
Yeah, that's it right there. Yeah, so
Okay.
I'm still involved. It's like right now I'm the external chapter president. So I'm in communications with like companies and like trying to get sponsorships. Like right now we have a sponsorship with Stripe, and they're like a software engineering company, computer science company. And so like they're providing awesome opportunities for us. And so hopefully our members can find jobs through them.
That's a good idea. That's good. Yeah, you one thing I noticed about you, you always kind of like a leader. You know, you weren't just kind of like doing the work. You're also kind of helping out the teachers and helping out all the other students and whatnot. I remember that. That was definitely something, you know, made an impression. That's cool. That's good stuff. So okay, so you left West New York, and boom, going to Brown.
Mm-hmm.
All right. Now, you know, so at Brown, what are you studying?
Yeah. So I'm studying biomedical.
Wait. This is my shop.
Yes. Oh my God. Actually, yeah, you're the reason why I started Riley the Engineer. You're like, hey, Riley, you're doing these projects. How about you like post these? And I was like, you know what? That's a great idea. So I think I started off as Riley the Riveter. And I was like, you know what? Let's change it. I'm an engineer. I'm Riley the Engineer.
Yes.
So you're the reason why you're doing this. So thank you.
That's so awesome. That is such, oh my God. All right, you made my day. All right. Anyway, that's good enough. See you later.
I look for that.
No, that's awesome. You know, what a good thing. Yeah, I remember because I think that not a lot of people know the story about Rosie.
Yeah, Rosie. Yeah.
Yes, not a lot of people know this story that during World War II, while most of the guys were in service, they would be on the front lines or driving tanks or whatever it was. The girls were in the factories, believe it or not, actually building the airplanes and the tanks, and there they are. And this is real. And the funniest thing about it is that Marilyn Monroe was in the factory. Okay, she was in the factory building drones in World War II. And see now, obviously there's a highly stylized photograph, right? And so Life magazine did like an amazing, they shut the lights and they lit them well and they made them look amazing. Like, they are heroes, but they obviously made these shots like amazing. But one of the models, like one of the people in the shot, the photographer was like, you should be a model and we'll do another shoot. And that was Norma Jean. So if you go here and you put in Norma Jean in the factory, here she is. This is Marilyn Monroe working on a drone. This is her. She's a factory worker. She's got her ID on her belt and everything. Like, that's for real. And that is actually, and that's where the photographer found her. It's like unbelievable, the stories that came out of World War II, and that nobody really knows these stories. So when you came to the shop, I told you about this, and then you made I didn't know you were going to make an Instagram out of it. It was so cool.
Yeah, it was honestly an ode. It was an ode to like all these women, and also just kind of like pushing more like other girls in STEM. Like, guys, like we can do this. Like, I'm sick of seeing like it's great. All these other guys. I want to see some girls in here too. Like, we can do it. Like there's nothing holding us back.
Yes, exactly. And then you did a penny battery with me.
Yes. Oh my gosh, I remember that.
That's so funny. And the vise that you're using in this photo, this is a Wilton vise. And there's this little fact about it you should know is that this part of it here is actually shaped like a bullet, and it's because this was the main contract for World War II. Wilton got like a ton of the contracts, and they had to make it like a stylized looking thing. So it was for the ammunition that they were building. And not that I'm trying to promote weapons or anything, but in World War II they made weapons. So this was the vise that a lot of the companies bought, and it's in the shape of a bullet. Yeah, and they haven't changed it to this day. So anyway, very cool. All right. So okay, so what are you doing at Brown?
Yeah, so there's like where do I start? So like, well, in this photo, I was taking a class. It was called DNA-based biotechnology. So in that course, literally we extracted our own DNA, and we were looking for a specific gene like in our DNA. So like we couldn't choose things like, oh, like will we get cancer or will we get diabetes? We had to choose like other stuff. That's what 21andMe and all those other genetic softwares are for. I gotta pay for those, But amazing class. So like, yeah, so you see all the different tools we have there. I was doing gel electrophoresis, so like just like separating these different genes. It was overall an amazing course. Very hands-on, like lab-based completely.
This is amazing. And so, what are you doing here? Like electrocuting it or something?
Yeah. So that's not electrophoresis. So in the first image, I was holding a gel, and so the gel gets placed. Yeah, so right there, that's the gel. And it's like a thick, it's kind of like a rubber consistency. And so like going back to the other image, we place that gel onto that like plastic, this container here. And then we run like lines into it, and we run electricity going through it. And so the DNA goes, if I remember correctly, it's from like negative to positive, because DNA has like a negative charge. So it's attracted to the positive, and we can like see the different genes, different sizes, and it's absolutely amazing.
Wow, that's interesting. I had no idea you could do that. So it splits the gene, or what does it do?
Yeah. So we're cutting. So what we did is that we cut the different segments up. So like the gene that I was looking for, I knew it was between a certain, I guess, DNA strand. And so there's chemicals out there that can actually isolate these specific strands of DNA. So I put in, I think it's like one of those, it's been a while since taking this course, but it's one of those chemicals there that I put in, and it separated that segment. And so when I was running gel electrophoresis, after a certain period of time, I expected this segment. So you're gonna see like a bar. I don't think there's any other photos, but you're gonna see like this like bar. There we go. This is what we're looking for. So we're gonna see like a certain pattern with these like DNA strands. So each of those are like different pieces of genetic material. And so yeah, so we're looking for the one that kind of like fits the gene pattern that I'm looking for.
Wow, that's so cool. I had no idea. I wouldn't even know the first thing about this. You know, this is like it's like you're talking about aliens. Like I'm like, okay.
This was like the very first course I took here. It was insane. Just like starting off
Wow.
with this, I was like absolutely insane.
Okay, so it's nice because it's like you're actually doing stuff with machines and chemistry. So it's like electrochemical. Electrochemical is kind of like underrated topic. Now, what did you find? Is it something bad? You probably can't tell us.
Oh no. So in this case, we picked a gene that was like, I think I had chosen a gene that was like whether I think it was like it has to do with like fight or flight. So if you had this like certain strand, you're more likely to fight, or if you had this other strand, you're more likely to flight. And so I think because of how like my results came out, I think they were inconclusive. So I had to like run more tests to like get a better strand because I'm cutting this DNA, these strands. I'm like putting the right chemicals and stuff like that at the right times. So I had to like check that. So unfortunately, yeah, I couldn't figure out what I guess like habit I have, but I don't know. I'm a bit of a fighter, so I'm thinking I have I have a fight gene.
Oh yeah, hell yeah, absolutely. That's awesome. What a cool class. Now, what's this right here?
Yeah, so this is the Brown Design Workshop. So this is my absolute favorite place on campus. So I think in that photo, I was taking the Engine 30 course. That was like the introductory engineering course. And so we started off with the wood workshop. And so we all made these toolboxes. And like to make those toolboxes, we learned different series of machines. So we worked with like hand tools. The first thing is like making us suffer, you know, just like pole saws and just like normal like saws, like cutting through those. We use band saws. What else do we use? I think we use a miter on this one as well. What's the other tool? So yeah, different things just get like used to like using these different machines in this workspace.
That, you know, it's so funny. I tell people all the time that, you know, if you want to go to engineering school or even in college, you're probably going to do something hands-on. And
Yes.
if you're not applying what you learned, I'm not sure what you're even doing anyway. Like memorization's kind of like only a one piece to the puzzle. And I'm not sure people believe me, but here are the photographs. Here you are doing wood shop at Brown.
Exactly.
I mean,
So
it's like
the biggest thing is like, yeah, with engineering, it's all about prototyping. You have to prototype your ideas, you know?
Yeah. And if this doesn't validate shop class, I don't know what does. Like this is like unbelievable, you know? And you know, and at MIT, at any school that has any, you know, good engineering program, they're gonna have an application area, you know, because otherwise, how can you try out what you're trying to do? You know?
Mhm.
Very cool. So that's this workshop right here.
Yeah, that's the whole. So that's actually an older image, but that's essentially the space. Like we have actually more machines. We have a giant like shop bot in there, and a few other machines that are missing in that image. But yeah, so essentially that's like the workspace of the campus. So it's open to anyone from engineers to literary arts to musicians. Like anyone can come into this space. And so we teach you how to use these different machines. We have different workshops from like woodworking, laser cutting, 3D printing, metalworking, and once you take those workshops, you have free range, so you can go around, use whatever machine you want.
Oh, I see.
Mhm.
So they kind of have like a prerequisites you could do, and then through the prerequisites you can get signed off so you could do other stuff at the shop.
Exactly. Yeah. So just to make
Oh,
sure like, everyone's
I see
certified.
something. I see something. I see
Yes.
something. I see something.
Yeah. So
I
that's
see
what the team.
Formula SAE.
Mhm.
Oh yes. Oh yes.
They're
Racing.
yeah,
That's
I'm not on
cool.
that team, but they're absolutely insane. Like their work, like their cars are amazing.
Yeah, it's serious. That's basically miniature Formula One for college. Cool. Very cool. Look at all this stuff going on. This is awesome. So here's Brown College kids working on like real stuff, like actually making stuff. Hey, is that you?
Yeah. It was one of our design challenges that they're like, all right, let's make an exercise machine. I think it was one of those squat on a yoga ball, so that's why everyone's like spotting me.
Yeah.
Yeah.
Nice. That's awesome. Looks like you're having fun. Oh, that's an old lathe. There you go. We have one of these old lathes at the high school. I don't have a new tool yet, tool holder. That's a quick change. I have one, but I didn't install it yet. But so this is great because this validates having, like, imagine if you're exposed to this in high school. I'm sure that's a huge advantage going into the college.
100%.
Okay. All right. Very cool. And I got these mats for my table as well. These are like, otherwise your table gets all scratched up. It's great. All right. So you became sort of like a shop, like an apprentice, but also someone who monitors it.
Yeah. So we're called monitors. So what we do is essentially we like run the space. Oh, real quick, that's our vending machine. It's full of snacks and also electronic components. So you can get an Arduino in there. You can get some like breadboards. It's an awesome machine.
Do you know what's funny? They have this. I saw this also. We spoke about this before. This is the same concept is at Dartmouth.
Really?
Yeah. Dartmouth has a machine shop, very serious machine shop. They do the same thing because they're tired of students not having tape or X-Acto knives or all the stuff that you need in the middle of the night.
Safety glasses. Look, they got Raspberry Pis in there. Ones you can eat and ones you can code with.
Oh, it's so funny. It's true. Look at that. Oh, a voltmeter. Oh my God, that's awesome. Oh, what is this? Oh, okay. Not here. But there was like a link to their page. BDY vending machine. Interesting. Okay. Don't shake it.
Yeah.
Yeah, because that's stealing. It'll just drop down. Look, USB cords. Awesome. 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 I love it. That is so cool. Let's see. Where was I? Oh, okay. Anyway, yeah. So I lost my place. But basically, how did you become you're kind of like a foreman there?
Yeah. So monitors we apply. I think the process is like every spring we have applications come out, and then like if we're accepted, we come in, do an interview, talk about why we want to be in the space, and if we're hired, we go through a whole like training periods. We call like MIT's monitors and training, and then once we pass that, we actually do a big project. So I think on my Instagram on Riveter Engineer, I have like my final project of like my contribution to the BDW and how to make it a better space.
Oh, that's awesome. I want to see that.
Yeah, definitely. It's I think there's like 4 panels. Let's see. Definitely up higher.
Okay.
There we go. Okay, middle one right there. There we go.
All right.
Yeah, so like so when you're training, after you learn all the workshops, you have to like come up with a project that utilizes like at least 2 or 3 of the different workshops that you learned, and then just try to find a way to improve the workshop. So right now I'm in our 3D printing area, and like one thing that I always noticed was that a lot of people were like, oh, like what are the settings of these printers? What does it mean to have 15% infill? Should I put 100% infill, or is that a waste?
Here.
Yeah, so I made all these settings in the back, so it's like easier so people can like visualize what these mean.
That's a great idea. You know, this is what they need at, the little 3D printing area at Memorial. This is a great idea. And I always thought it would be interesting to have students before they graduate contribute something back.
Yes, exactly.
Because you got so many students there and you only have like there's like a handful of teachers if you're lucky. And so like the teacher can't do everything, but all these questions come up. So that's a pretty good, I like what you did there. That's pretty good. Nice. The infill. And what's this one?
Let me see. Ooh, I forgot what that one was. That has to do with like layers. So like how many layers to incorporate. And I think the one with the deer antlers, that has to do with like supports. Like how many supports do you have? How strong should they be?
Here you go. Raft versus shell.
Yeah, so the shell's like the outside area.
Okay. That's awesome.
You can probably do the different type of supports now because there's so many different kinds.
Yeah, that's true. So right now, actually, in that photo at the time, we only had MakerBots. But now we moved on to these new printers called Prusas. They're really, really great. So I guess like my settings right there kind of still apply to the Prusas, but I'm looking to make new posters to like update it, with the new machines.
Nice. We had a 3D printing startup company on here. Young dude. Let's see. Shop class podcast. This is a good. It's actually to give you some insight into entrepreneurship while having a day job in the field of 3D printing, which is super competitive because like there's so many of them. This is it right here. Let's see. We were just talking about it. Oh, here he is. This is Joe, and it's called Mantis. And you don't have to set, like Duke probably knows more about this than I do, but you don't have to set the board. It sets like the bottom. You don't have to set it. It sets itself.
Level it. You don't have to level it. So the print head will touch different parts of the build plate and layer it for you. I'll tell you, it's probably right now one of the easiest printers to use because the advantage is they already have like the Cura settings behind the scenes. So all you have to do is I have the kids build it in Tinkercad, and then they can upload it to the Mantis cloud, hit send, and it takes the Tinkercad STL file, and instead of going through like a Cura slicer, it goes right to the 3D printer. So if in a school situation for kids, if they're using it for the first time, just to get them hooked on it, it's a great printer to use. But if you're going to use a printer, over a period of time, you're going to want to experiment with the Cura settings, and it will also allow you to do that. But it's also hooked up to Octoprint, so eventually, if the kids, if they hook it up to their Chromebooks, they can send it to that printer and then, look at it, watch it print on their Chromebooks or even on their phone.
Whoa!
So
forgive me. So what's a Cura setting? Is that just how it slices?
That's your like Ultimaker. That's like a pretty popular slicer programming tool. So the 3D printer has to understand the language and learn how to put the build settings in there. So if we're going to have some type of like build supports on there, the layer depth, thickness, the infill, you can all manipulate that on the speed on the Cura settings.
Okay. Let's see. Oh, here it is. So he's still going strong, huh?
Yep.
That's the world's easiest printer.
The high school teacher just stopped by the other day, and I was talking about the 3D printers we have, and he's like, well, "I just want the kids to print something." I said, "You know what? I'll contact Mantis Printer for you." And I did that on Friday, and they gave us 2 quotes.
Oh wow, nice. Yep. So yeah, I mean, like it's for starting out, right? But eventually, you want to mess around. You want to adjust your settings. That makes sense.
If you're going to concentrate on a 3D printer, you're going to want to, mess around with the settings. But for like an introduction for my middle school kids to the 3D printer, just to get them hooked, this thing's awesome.
Nice.
And it does have the option if they want to, dive deeper into it, they can do that as well.
That's cool. Okay. So, all right, this is cool. And let's see, going back here. Okay, so now once you got, okay, now I want to hear about this crazy thing you did where you went to biomedical engineering internship. Is this it? Oh, I'm not sharing. Sorry. Okay. All right. So Riley.
Yes, there you go.
Okay. What is this situation going on here?
Yeah, so last year I had applied through the National Science Foundation. They have a thing called the REU. So it's a research experience for undergraduates. And so through there, I got accepted to this program, and they sent me to New Mexico Tech in Socorro, New Mexico. And I was there for 2 months. with this lab with the so that right there, that's like the lab I'm with right now. I think further down you'll see the New Mexico Tech.
Here, this is it.
There we go. Yeah.
Cool.
Yeah, so that's a site. So I was there for 2 months, and that program was insane because they really really just like brought us into like the whole like lab research experience. I had like a really great lab. I worked so I studied traumatic brain injuries, and I worked under Michael Antardis. Actually, that's one of the researchers that I worked with, a grad student. Her name's Mindy Marquez, amazing woman as well. Gave me so many advice, honestly, so much advice. She's a grad student, and so now that pushed me to really go to grad school now. But yes, I studied traumatic brain injuries, and more specifically, we're focusing on what makes these injuries so deadly. So it's not the initial like blunt impact. So it's not like the first blast or whatever. If you get like hit, it's the after effects that we suspect might be more like harmful in these cases. So it's actually being funded by the Air Force. So it's like I can't really show images or can't show results because like it's all confidential information. But amazing learning experience.
I like it. She's like a part of it. She's training to be a spy already.
Right.
She's like, listen, I could tell you, but then I have to kill you.
Exactly. I didn't say it, but you know.
Wait, so how did you go from engineering to biomedical engineering?
Yeah, so I started off, I knew I wanted to do engineering because I just love the idea of just like, once again, design and innovation, being able to like solve problems, but not just like, oh, like come up with a solution, like handcraft your solution, okay, hand make it, you know? But then I also love the idea of just like improving quality of life, okay? And so I was like, you know what? How about I combine that biomedical engineering? So that's honestly, it's a very big field. So there's so many things I can go into, whether it's like prosthetics or focusing more on like the chemical side, perhaps. But that was like my happy medium between like mechanical engineering and like this life sciences.
Interesting. You know, I think the most important thing that is like you understand it, but it's overlooked is I think, you know, people got to realize if you want to grow and you want to help, and you want to like grow your career and also make a lot of money, what you got to do is figure out how to help people. So as long as you help people, you're going to be fine, you know, and you clearly know that. But I didn't know that in high school. And a lot of kids, they're like, oh, how do I get rich? And I'm like, just figure out how to help people. So now you're like, okay, how do I work on engineering, but working on personal health, you know, helping people? That's great. You know, that's a great thing that you're doing.
And honestly, it's even more of a plus when you love what you're doing. Because one thing, just like doing the job, like, oh, I'm doing it for the money. But if you love it, it's like, you're really going to go far.
Yeah. Yeah. Now, what about, like what, and so you studied brain injury. Like, did you guys do like MRIs or how do you study it?
Yeah, so over the summer, so we weren't like dealing with like actual brains. We had just like very like simplified models. So we're using like these like hydrogel or like these like gelatin models like of the brain, and we actually 3D printed skulls as well. And so me and like this mostly the other grad student I was working with, he like 3D printed and assembled this massive drop tower, and it was guillotine style. So imagine this like weight on this guillotine like device, and that was like at least 4 kilograms being dropped onto the skull. And so we were like recording it. So we were seeing like, okay, like the movement, seeing how these like shock waves go through the brain, but then also using ultrasound. So, you know, the same ultrasound you use to kind of like to see babies, we're using that to see like what's happening in these, like in the brain, in these folds.
Wow.
So much.
I've never actually like touched a brain. Is a brain kind of like it's just a big gooey thing?
Yeah, so like our models, they weren't really biofidelic. So they weren't really like close to the brain. The only, I guess.
Did you say biofidels? What is that?
Biofidelic. So I think that has to do with like how realistic it is to like to biology or like to like life.
Yeah, this is cool. I'm having a moment. We're on the Shop Class podcast and we're talking about brains.
Right?
Engineering brain impact test. Like, This is awesome. I can't believe it.
It's like these models, like they mimic the like material properties. So it's like how they felt, I guess, how like strong and squishy they were, I guess, mimicked how a brain would, I guess, kind of feel like.
Wow, that's
Well,
awesome.
I am a real brain. Disclaimer, unfortunately, that wasn't part of the program, but we'll love to touch a brain, a real brain.
Okay. So now you smash it with like a guillotine hammer.
Mm-hmm.
Okay, like a hammer on a slide. That's like almost like a drop hammer or something.
Mm-hmm.
And then you watch to see what happens, and you're thinking about the impacts, and you do scans and whatnot. That's awesome.
Mm-hmm.
That is so cool. I mean, it's a real thing. Everyone wears helmets when they go skiing now. When I was a kid, we didn't wear helmets. Now you do, and I've saved myself several times. The worst is it's not what you think, where you'd hit forward.
Mm-hmm.
It's slipping back, and then your head whips back and hits the ice.
Yes.
And so it's that. I'm sure is that one of the injuries that you guys look at?
Like that's what it is. Like that. It's like that secondary
really?
impact. So it's not the initial blast or the blunt. It's when. So think of like a soldier, like whoever, like a explosion goes off. It's not the blast. It's when he hits the wall or hits the ground. That's what we're like focusing on.
Wow. What do you think, Duke? Oh, you see.
Wrong button.
Oh.
Yeah, it's awesome. It's awesome. And that's a lot of stuff going on with this with the concussion syndromes right now. There's a lot of studies going out there with that. So this type of research is definitely needed.
When I was a kid, I was in a fight and my head hit the ground. I don't know, like 5th grade or something. And my head hit the ground and I saw stars. Like, you know how like in the cartoons they show tweet, 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 and there's stars and birds? That's real. That is real. That actually happens. Like I smashed the ground and I saw like stars. I was like, what is going on here? You don't even know what's happening.
I had that happen in a football game once.
Yeah, if you're an athlete, and Matt will tell you, playing football, that helmet, it protects you, but it also gives you a false sense of security because
yes.
You think you can go out there and hit another helmet with your helmet, and the stuff that they're doing now on the pros, the helmet to helmet contact, that is dangerous. And I've seen stars. I've seen stars playing football, seen stars playing baseball, seen stars boxing with my friends, and now I'm probably paying the effects from it now.
Wow. Matt, what about you?
Going through it.
Yeah, I remember I think it was junior year. We were football game and I was on defense and I made a tackle and the running back dropped his head and his side of his helmet hit me right in the helmet. And I came up a little dazed and every time I blinked, you'd see the little lights. And the next play I made a game-saving interception, so I guess I was okay.
It triggered your killer instincts.
I guess. Like it was just enough of a little shock to like, whoa, but I was very fortunate. But heck, I remember one time our quarterback, he got dinged real good. It was early in the game and played the rest of the game, getting ready to get on the bus. He started throwing up. He had a concussion, played most of the game with it.
Whoa.
But back then you just kind of either went to a doctor, rest or whatever, and you went to practice on Monday. Now you got to go through protocol and get cleared. It's I think like a minimum 3-day process just to even make sure.
Wow. So Riley, you're studying stuff like this.
Mm-hmm.
Wow. Now, what are some of the solutions? Like, is the engineering in the looking at it, or is there an engineering solution in the helmet? Which side are you guys, or is it just research?
Yeah. So with what I did over the summer, so just purely over the summer, we were just trying to understand like these impacts better and just understanding what makes them so detrimental. So like whoever the next researcher is who comes in, they'll hopefully find out, oh, this is what it is, and then find a solution or another method that kind of like, I guess, resolves that, So that was just like one part of the process, so one part of the process.
Yeah, that's cool. Ah, that's awesome. All right, and now what are you working on now in the fall?
Mhm. So this fall I joined the Tripathy lab here at Brown, and so I'm doing something completely different, still related to BME, but we're focusing on like analyzing single cells, but also like dissociating the cells. So what that means is that like, we take a tissue or like a biopsy sample, and then we want to get it down to like 1 or 2 cells, okay, and then analyze it from there. So we're trying to like so I think right now the person that I'm working with, they invented this new device. So it's like novel. There's like nothing like it right now, or it's like that's like being researched. And so we're just trying to like make that, I guess, current device like optimize it and then hopefully eventually patent it.
Oh, wow.
Mhm.
That's awesome. So basically what's happening is that
You're kind of like you're really on the like at the deep level of all these things, like thinking about DNA and brain impacts and measuring, and this is awesome. You must be so excited about this. This is like now. What do you think, as the shop teachers? What do you think we should be doing to to like what would you first of all what kind of advice would you give yourself from like high school, and then what would you tell the teachers about getting people prepared for engineering careers?
Mhm. I think one thing I would tell myself is like actually take the shop class. Like I honestly like regret not taking a class with you. Definitely seems like awesome. But I think
You would have been a great welder.
oh my
The
god.
girls are the best welders.
Really? Oh my god. I remember Kelly Coca. Remember her? You're above me.
Awesome.
Her mask. Oh my god.
Yeah, Kelly was great, and then she went straight in to be a welder on the racing team.
Yes, yes.
Which was very cool.
Close to it. Yes.
Uh-huh. And so you wish you took the class, okay?
And what do you think? What can we do as teachers to kind of get students ready, or even attract students to our program?
Yeah. So I think there's like different things. Like I think one thing, like I'm not sure. Well, I think you guys had spoken about it before, but like incorporating 3D printing, like make that like a big part of, I guess, like the whole like learning process, because there's so much potential with that. And like the whole like idea of what we call design process as well should be like really emphasized to the like what's the issue, let's like research the issue and then create your design it, talk to people and like create whatever solution it is and like actually make it, definitely having like products, like final products, is really really helpful. Like that's what really brings in these students.
Oh, I see, the design process.
That's what it is, the design process. That's huge, even like with engineering in general, not necessarily if you have to make a prototype, but like that whole just like understanding what's the issue, planning things out. Communication is huge, especially in college. You're constantly talking to people, you're constantly networking, so you need to know how to talk and be able to explain, this is what I want to do, this is why my project works. Like they need to be able to explain themselves, and I think another thing you're talking about before, like no, with like my design workshop, how we have like a final project to improve the space. I think actually incorporating that with your students, like, hey, like as like a final project, like a final for the class, like what's one way you can improve our shop? Whether it's like, I don't know, changing the machine orientation around, like location, making the floor, make a better floor plan, or I don't know, making like signs, stuff like that. Like some way to like give back, I guess, to the shop community.
Okay, that's pretty cool.
Yeah. Now, so now
Also, what do you think what was your most valuable what do you think you used the most from that you got from the high school STEAM program?
I definitely think, I guess like the real word is like mentality, I guess. Like I remember Barkman always telling us like because he'd give us projects like literally 2 or 3 days before we had to like get it done or when it was due, and he'd just be like, make it happen. So whenever I'm doing a project or I'm doing doing some crazy like challenge, I always think to myself like, what would Barkman say? Make it happen. And like that's just like one of the things that really stuck with me, like throughout my design process and like time here at Brown. Just like make it happen.
That's awesome. Yeah, Barkman's great. He wasn't always the supervisor of that area. He actually was. He became. He was a science teacher. Then he became supervisor of science. And then I went to him and I said, "Listen," I said, "I think you should be supervisor of industrial arts," because at the time they just sort of like shoved us over to the music department. And not for nothing, but the music supervisor, he wasn't interested in growing our department. Whereas science is involved with competitions. They're always trying to up the ante with the equipment. They're always trying to upgrade the labs. And so I was like, that is what we want. And someone who understands that you have to use your mind and your hand to make things. And he understood that. So I was like, please do something. Maybe you could. And at first it was kind of difficult because you can't just take another department. So I don't know how he did it, but somehow he was willing to take on a few more teachers. And then that became the STEAM department, which grew huge. Everyone was so excited. And then we got robotics involved. And that is awesome.
Yeah, he made it happen, you know?
Yeah, he's great. And as far as the design process goes, you know, it's funny. I think that is a super underrated topic. You know, the thing is, what I tell the students about the design process is that basically the word engineering is scary. You see, so people say, what is engineering? And if you ask a class, they'll say, math. Like, okay, that's part of it, but it's not engineering. That's just a tool for engineering, you know? And someone else will say, coming up with something, being creative. Sure, but that could be art class, you know? So the way I define engineering, and this is just my personal thing, but I think that it helps, is so it's different from science. Science is controls and variables, evidence, stuff like that, right? And narrowing down the possibilities, right? But engineering is coming up with a measurable benefit to the end user. So like you might use science to get there, but then can you measure this improvement you've made? Maybe it's a stronger bridge, but it's lighter. Maybe it's a brick that holds more weight, but it doesn't cost as much. You know, almost like we've been doing a lot of build science. So recently, so Matt, since he builds houses, he's involved with what they call build science. So when you're a contractor, you're not just doing like, oh, you're going to build a house. That's great. But that's the old way. The new way is, how can you make that house efficient? So they're doing stuff like where they're worried about the thermal efficiency of the house. And so they have these things called R ratings. But Matt could talk more about it. But to me, that's engineering. You're coming up with like a measurable benefit that you could measure in your energy bill, and it's the benefits to the end user, you know? So I think that is an exciting process that you can only get there by having a baseline and then a creative idea. So it's like your baseline and then your creativity, and and then you keep on going and you fail your way up to something that actually works. And so this is the process. And so that's super exciting, right? You know, and so I don't know it's hard to convey this though. Like, how would you say this if you had like less time than I just had? Like, what would you say to a student, like, if they don't understand what engineering is, you know?
Yeah, honestly, I agree with that. It's like with everything you said. But oof, yeah, I have to like think of that. But essentially, just like just making things like more efficient, you know, designing and just like improving quality of like life and everything, you know, I guess.
A lot of times we use the design process in like everyday activities.
Yeah.
You know, you have a problem. First thing you're going to do is go on the internet and research what other people have done, you know, research your ideas. Then you're going to come up with some of your own ideas, you know, then test them out, see if they work. If they don't work, back to the drawing board. You know, but, you know, tech ed, we're just putting those designs on paper. We're letting the kids aware that there's a process out there. You know, they do it in the back of their minds, but we're always doing it in all kind of activities.
Yeah, that's cool. Matt, how do you describe the build science? Like if someone said, oh, hey, that's great. You guys teach kids how to use a hammer and nail. Like, it's so much more than that. And it's hard to describe
Yeah,
it.
Well, actually, not really. Building science, and I actually said this on a podcast one time with some of the building science friends. I was like, it's once you break it down, it's just simple physics. Hot to cold, wet to dry, air moves vapor. Things need to dry, otherwise they rot or mold. I mean, doesn't have to get any more challenging than that. Now it can when you're starting to get into other, when it gets starting getting really technically difficult, like what we're dealing with right now, it's like if you build a house too tight, which is the goal to save energy. Well, now you have to make sure the people inside can breathe clean, fresh air. How do you control that with, mechanicals? When you start, if walls aren't drying, you still have to worry about like the temperature delta from outside to inside and condensation points and dew points inside the wall, things like that. That's where it starts getting super technical, where that's where I just call my friends and be like, hey, is this wall gonna, even though it's a great wall, am I setting it up for disaster or not? So thing is, I got friends that are way smarter than me, and they have super expensive software programs that they type in parameters and boom, it tells you what's going on and all that cool stuff. But yeah, I mean, the simple part of building science is literally basic 6th grade physics or science class. I mean, high school physics. It doesn't really get much more challenging than that.
Nice.
Yeah. All right. What now? Okay. So I got another question for you, Riley. I guess in biomedical, this is going to be a big question. Where do you think your industry is going? Like where do you see yourself in your industry, and where do you think that whole thing's going?
Yeah, that's definitely a loaded question.
Yeah.
Yeah. There's like, the BMEs is really broad. But I guess like personally, I'm still trying to figure that out. Like, that's why I'm joining all these like research groups to kind of like see like, okay, do I want to focus more on like brain issues? Do I want to do whatchamacallit, work with cells? Or actually right now I'm taking a capstone course. So it's like a BME innovation design. And so we actually get paired with clinicians come in and they tell us their issues, and then we choose what projects we want to solve. So right now I'm on the prone pillow team. And so because of COVID, a lot of people have to be put in a prone position. So do you guys know what prone position is or at all or no?
No.
So it's a certain position where you're on, usually you're on like your stomach, but it's to help you breathe. It's to like open your air.
Oh, I heard this recently. When they lay you on your back, let's say you got serious COVID. I'm not regular COVID, like serious COVID. If you lay on your back, it all drips down to your lungs, right?
So I think it's something like that. Yeah, but like I know a certain position, I believe it's more so when you have to be on your stomach. It helps you to breathe better. But the thing is, these people, I didn't realize that these people are in this position for like 16 to 18 hours. And so they'll get like pressure ulcers on their face. Because they'll get people with like bigger stomachs. So, think of like a lever. If someone has like a big stomach, they're putting all the pressure on their face, on their shoulders. So we're here, we have to make a solution and figure out a way to like help these people like either reduce pressure ulcers or even just prevent it. So
interesting.
Yes, I'm getting like that aspect from like this course. But we'll see like where I fall, I guess, in this like BME industry. Like after undergrad, I'm gonna go to grad school. So more time for me to do research and kind of figure out, I guess, like where I want to fall.
That's interesting. Now, what is this capstone course? Is that is that Brown or is that the MIT online course?
Yeah, so that capstone, that is through Brown. So I think a lot of like engineering schools have it. Essentially, it's just like a course where seniors, it's usually just seniors, but you apply everything you've learned from all of undergrad into like a real design problem. So like, it's literally, it's like we're dealing with.
Wait, is this your senior year?
Yeah, senior year.
Where did the time go? I can't believe it was 4 years ago you were in school. So that's cool. So what are you gonna do with what are you gonna do as far as the capstone project?
Yeah, so right now we're in like the early design phase. So right now we're communicating with the clinicians. They actually have directed us to a few nurses. 'Cause, like, one thing is like hearing it from the doctor, but we actually want to hear it from the people who are handling these patients, the nurses that have to lift these people and like put them in these positions and understand like what's the real problem. Is the problem the device? Is the problem the different, I guess, like getting the person in the position? So we're still in this like, so we're literally going through the whole design process. And so right now we're still in that research, understanding the problem, making a need statement phase.
Oh, okay. So your first, like, what is the problem? That's a definition.
Mhm.
And then you're going to start to work on, I guess, a base, like, what's the next step?
Yeah, so then from here, we continue doing research, and then that's when we start like looking up like, okay, what solutions are out there? Because a lot of times like there's a good solution, but it's not good enough. Like sometimes it needs like a little extra push or something to change to make it like the solution, or like to make it work better, you know. So I guess that's like our next step, just kind of like researching that. Next, because it's actually a whole year course. So this year is mostly just like, sorry, this semester is mostly designing it, maybe doing some modeling. Next semester is when we actually get to prototype and like build these things.
That's cool. So you're going to make a product,
Yeah.
and it might be like some way to hold a person, or maybe something that solves the problem.
Exactly. We're thinking like some way that like either it just alleviates the pressure from there, but you know, we have to consider different people, like different sizes, because once again, you can have like a tiny woman and this like huge man with a beer belly. It's like we have all these different people that we need to account for, you know?
Oh, yeah, that's true. I see.
Mm.
That's cool. And what is there anything else you want to tell us about the Brown experience? What do you think so far? Did you obviously you like Brown, but what any recommendations or anything like that?
Honestly, you know, I love it here, and like I think the biggest thing for anyone, even at any school, because actually also we have like another Brown Memorial High School student. Do you know Ronnie's brother, Ronnie Jerez? I don't know if you remember him. His brother Ivan goes here as well.
Oh, cool.
But anyway, so it's not just like anyone, just like it's what you make of the experience. That's what it is. Like you can go to this amazing, like Ivy League or even like a state college. It doesn't matter where you're at. It's what you do at that time, what you try to achieve, what you make of it. And so that's
Nice.
what I'm doing here, you know.
That's good. And you're in Rhode Island, right? That's kind of that's Brown.
Yeah, Rhode Island.
What do you think of Rhode Island?
It's not bad. It's a very tiny state. There's a lot of public transportation, so I get to explore. Like I've literally gone to like one side of the state to the other, like all within one day, like on a bus. But it's a really, really great community. Providence is very lively too. So definitely recommend visiting here. There's a lot of cool places to check out, a lot of art places and studios.
Because the Rhode Island School of Design is right there, right?
Yes, it is. It is. You can actually get a lot of RISD students who come into the design workshop and also take classes here as well.
Oh, interesting. Okay. And it kind of shares the campus, right?
Yes and no. Like they're pretty separate. Like RISD is more so like on the hill. We're like more on the top of the hill. But we're still like it's like within walking distance.
Okay, that's cool. Now, how far are you from Boston?
Boston, I think it's like a 30-minute train ride.
Oh, that's like nothing.
Yeah. I've actually been there for design competitions as well. I think it's on my Instagram too, but I went to this one called Make Harvard. So have you guys heard of like whatchamacallit? Like datathons or hackathons? There you go, hackathons. They're like these like 24-hour coding competitions. And so Harvard University was like, you know what? How about something for the engineers instead of the computer science people? How about an engineering challenge? So I think it's not this image, but I know I'm wearing a green shirt. Down a little further.
This is the end of it.
Oh, that's the top. Let's go down.
Oh, down. Okay.
Yeah. So I think that image top. Yeah, I was back at home.
So funny. You're so into it. It's great.
I love tinkering. That's another thing. Just like making stuff. Oh, that's Ellen Ochoa. Do you guys know who that is?
Where?
That woman on the left. Ellen Ochoa.
Oh, who's that?
So she's the first female Hispanic American to like go into space.
Oh, wow. No kidding.
That's her. amazing honor.
That's awesome. Whoa, no kidding. And you got to talk with her?
Yeah. I got to speak with her briefly. That was at the SHIP convention 2 years ago.
That is
Amazing woman.
so
Amazing.
cool. And she went in the space shuttle?
Yeah, I forgot which shuttle she. It says Discovery, but yeah, she was the first female Hispanic to go into space.
You know that she's lucky because those shuttles were super dangerous. You know, two times an entire crew was lost. I remember when I was a kid, the Challenger. Everybody watched that on TV. That thing disintegrated. Nobody was found. Like instant vapor. Like the thing just blew up. And then another one, I think the last flight was coming in, and the bottom was damaged somehow. The heat shield was damaged. That's it. And it was damaged, and because of it, it actually let heat in and tore up the bottom, which then just took the whole thing. So like 2 crews lost. So these people who like these astronauts, they are risking their lives. It is no joke. Yeah, that is wild. Cool. Okay. So you did a challenge?
Yeah. So it was called Make Harvard. So it's one of those 24-hour makeathons. So I think they're in the photos there. So yeah, bottom green right there.
Okay. Yeah.
Yeah. So it was like me and my team. This was actually freshman year of college. So it's like Samia and Bree. We're still friends today. They're both studying mechanical engineering.
Oh, cool. Nice.
Yeah, so we're there 24 hours. We stayed up the whole time just like trying to make something. I think we were working with an Arduino. What were we doing?
Oh, you laser cut something.
Yeah, so I think we're trying to combine like a speaker and like a laser cutter. Like we wanted to learn how to use the Arduino more. We didn't get too much experience in that. It was like another team that was there. But yeah, like it's amazing. They give us all these materials absolutely free. The only thing we pay for is, of course, travel. But they provide the resources, worker spaces, machines, and we're just there to build and have fun, network, and just.
That's awesome. Nice. That's really cool. Yeah, it's always fun to like get out and like meet other college students at other places and stuff like that. That's great. This is so cool. You're doing so much stuff. Now, you sent me a little bit of a presentation here. I think we kind of went through all this stuff anyway, but let's take a look.
Definitely, yeah. That's where we're at.
All right. So this is the first one.
Oh, yeah. So like myself, yeah.
Oh, that's good. Where is that?
This was LBI, Long Beach Island.
Okay.
All
right.
I was like, oh, let's take up. That was like when I first got like my haircut, and I was like, I feel awesome. I need a photo right now.
Hey, you look badass. This is great.
My friend wanted to Photoshop a motorcycle underneath me instead of the bike.
Funny. No, you look great. That's cool. All right. Okay, this is pre-college programs. Oh yeah.
I was in JIT. So I was like one of the groups that we're with. That was actually part of like a music video we made for like about like math. A while ago, it's a little blurry, but yeah, great people. And they were all from like Hudson County as well, different parts of New Jersey.
Oh sure. Okay, that's cool. Nice. And this is Memorial.
Yeah. So there's some more photos from my Instagram. When we started using the solar panels, the bottom right. Oh yeah, that was part of the house project. The solar, putting solar panels onto the house. That was like when we were first starting it.
Are you talking with? Do you follow up with Carlos? How's he doing?
No, I haven't spoken to Carlos. Actually, maybe Kaylee might talk to him still, but no, I haven't spoken to him.
Okay, you guys got it. It's hard because people lose contact.
No, it's true. It's true.
Yeah. All right. And then this is now. Or
yeah. So these are other things I'm in. So I'm in SHIP, the Society of Hispanic Professional Engineers. Some like pictures of the workshop. I'm also in a sorority, Alpha Chi Omega. And yeah, those are the big things I'm on campus.
Awesome. You're so involved. It's great.
Yeah, those are like the projects, like making a laptop stand. That's like actually what my computer is currently on right now.
Oh, okay. Yeah, I could use one of those. That's cool.
Very helpful.
Nice.
Zoom age, you know.
I'm just starting to mess around with Arduino now, and I'm actually taking Fernandez's coding class. As
Oh,
yeah, like I'm a teacher, but I walk in as a student. I'm like, okay, I sit down with the students. I'm like, all right, what are we learning today?
that is amazing. Highly recommend that. Yeah, it's a
Yeah.
great. There's so many things you can do with it.
We're just starting with block coding now, but it's really helpful. All right, and then what do we got here?
Oh yeah, so these were the photos. So like this the image.
Oh,
of
there's the gel.
Yeah, that's what it is. So it's like a full, like almost like life size model. But instead of like a 3D, it's literally just a 2D extrusion. But it was huge. So like the people there are the people that I was with. I still talk with them. They're really, really great people. I know one of them goes to Quinnipiac University, so they're only 2 hours away from Brown, and we still chat. It's a great friend. But yeah, and also we went to like White Sands as well as another part of the program. Have you guys heard of White Sands National Park? Absolutely gorgeous.
No, is that in New Mexico?
Yeah, it's in New Mexico. It's like heaven on earth. Like just imagine just like white mounds everywhere. Absolutely like it's seeing pictures is one thing, but when you're actually standing there like next to these massive dunes, absolutely just like breathtaking.
Oh wow, look at that. That's awesome. I didn't even know about this. It's close to it's close to the missile range. Watch out.
Yeah. I think we passed by there too. Sandia National Labs up there too. They have like the giant like satellites. The VLAs are there. The very large arrays are there. We didn't get to see them, but that's there too.
Wow, look at this. That's awesome. So you walk on here and it's just all dunes, right?
It's all dunes. Like the sand is also like cool to the touch. So it's not like beach sand that gets hot. It's very cool. I forgot what the material is, but it doesn't heat up.
Really?
Yeah, no, it literally doesn't. We're all like walking around barefooted and just like, oh, it's absolutely insane.
Look at this. A little different than West New York, right?
Oh, just a tad, just a tad.
I was funny going out to these places. I always think of West New York when I go to these places. I'm like, wow, this is like as far as the eye can see. There's not one building.
Oh my gosh. Mm-hmm. Even in the hospitality too, people they just come up and talk to you. I'm a West New Yorker. Okay, you don't talk to people on the streets. Okay, if someone comes up and talks to you, they're gonna steal your wallet. They're gonna jump you. Okay, like you don't just start a conversation. That's a little sketchy. I don't know.
That's so funny. It's hard to describe, but like, yeah, like if someone talks to you and is nice to you, you're like, what do you want? But you go out here, people are just nice because why not? Yeah. That's awesome. Is this where you were? I'm just guessing.
Yeah. We were literally there. We just drove out to like the farthest, as far as the road can take us, and then we just like walked out into the dunes. So you just gotta keep track of where you're going, because if not, you will get lost, and they will have to call a chopper after you.
Oh my god, that's crazy. Cool. And where was the lab that you were working at? Is it close to here?
Yeah. So I think it's about an hour or two away. So it's in Socorro. Soccorro.
What's it called?
Socorro. So SOCO.
Yeah.
There we go, right there. Yeah.
That's cool. Nice. That's awesome. It's good that you're getting out there. Have you ever been out to this places like this before?
I've never left the East Coast before, so this was like a totally new experience.
Don't you find it like whenever I go out places like this, I always can't believe like how big America is. Like it's so much bigger than what it looks like on the map, right?
Mm-hmm. I agree 100%. Like honestly, like I have like no interest in traveling the world. I just want to travel the US. There's so many hidden gems here that like
yeah, you could spend a lifetime just traveling the US. There's so much here.
Exactly.
And you got everything. You got beaches, you got desert, you got forest. Like there's so many things. I'm not saying don't go out the US, but like it's just there's so much here,
Exactly.
Yeah, that's cool. Nice. All right. Let's go back to the thing. Where's the thing? I don't even know where it is. Oh, here we go. Okay. Present.
Riley, you talked about patents.
Mhm.
Are you involved in the patent process, or do you let the school take care of all that? Because we've had some guests on here before talk about patents, and some had positive aspects of it, and some were like, it's a lot of work for nothing at all because you're going to lose the patent later on.
Mm. I don't have like too much experience. I know like the grad student that I'm working with eventually will be pursuing one, but I think the way it works is that like whatever projects are done here, like at the university, it's not our projects. It's really like the university's project. So the patent's really like through like getting done by the university, if I'm not mistaken. So it's like it's more so like we're involved in the process, or like the grad students involved in the process, but it's mostly like under the school.
Let the school take care of all the paperwork. You
Yeah.
get to sign it. Do you have to sign any like confidentiality paperwork if there's a patent involved?
Possibly, like I didn't have to do one over the summer, but like they told me since we're working with the Air Force, since it's being funded by them, I might have to sign a confidentiality thing to make sure I don't release like any of my posters or any of like the data that I had. So all that's like secret and like kept with them. Don't want to see a red target on my back, you know.
What is the you took this MIT class, right? Is that online? What's that about?
So that actually was a program. So that's meant for usually for juniors, or yeah, for juniors, rising seniors, and so it's a program meant to just like it's a very intense kind of program where it's like you're taking these different courses. So I chose to take the EECS program, and so that stands for Electrical Engineering and Computer Science. And so I learned how to use the Raspberry Pi, a little bit of Arduino. But it's a big like time crunch, so it was completely virtual. This particular program, and I think it ran for 8 or 9 months, so it did leak into the school year. And so we're just doing like projects back to back. Like it was a massive time crunch for something that's like it was like 9 months long. There's so many things like being done, so many things that we were learning, and then like toward the end of the program, we were all brought to MIT for a week to present our projects, to like meet each other, to do some like final class work, and to actually build our projects. Because a lot of times like they sent the materials to us at home, but yeah, all the final touches were done at MIT, and then we presented there. Got to meet each other, networked. But that was a very, very intense program. Like I think at the time I was like, this was like the most challenging academic experience I had ever like been involved with at the time, because they also incorporated like literary arts, so they had like an English course and like a math course as well. So they were really trying to make us like well-rounded.
Wait, so is that part of your college credit for Brown, or is it this is totally separate thing?
This is totally separate. This is like its own. This is like NJIT has those pre-college programs. That's MIT's pre-college program. So it's meant for like underrepresented students. Like students who don't have like a lot of resources, and so it's meant to get them to also get into good schools, because a lot of times like if you're taking a program at MIT, like these big schools are going to want you, you know.
Yeah. Wait, and when did you do this? Before Brown or during Brown?
This was in high school. I did it in high school, so I did it
no kidding.
What is it, junior year? Yeah, junior summer, so like going into senior year.
Wow, no kidding.
Yeah.
So what is that? So it's kind of like you're enrolled in college in a way. So it's multiple classes.
It really, honestly, now I think about it, it really was. It was like a really big introduction to college. I just remember pulling like late nights. Like literally, I would work from like, I want to say I'd wake up at like 2 p.m. and I'd work until like 5 a.m. in the morning, and then just like sleep during the day just to like do this class. I needed peace and quiet because it was intense. Like these very intense.
Wow, that's interesting. What are some of the projects you did?
Yeah, so some of them so it's a lot of Raspberry Pi. So like making games. So we're given like the Raspberry Pi, we're given a monitor, and then like the other like electrical components. So we're doing like these like mini projects. But then like for our final project, we got to choose like literally do whatever we want. So I wanted to make a Morse code converter. So like you type in whatever like the message is in Morse code, and it would like translate it, and like the message would appear on the screen. So like that was a project. I think I got like halfway there, or like I was almost done, but just like time wise, the guys like it's okay, just present what you have, like present the progress and like what steps you're gonna do next. But that was like an insane project as well. A lot of work.
Interesting. I don't know if you know, but Thomas Edison got his start as a Morse code reader.
Oh, I know that.
There you go. So you were working on the same problem that Thomas Edison was working on. He went far beyond this, and then he got into like recordable sound, and then he got into like, I don't know if you know, but Thomas Edison is the reason we have recordable sound. I'm sure it would have got invented eventually. Pretty incredible. Oh, here it is. This is a picture of the first machine ever. And it would just put those things. So when they say like the Beastie Boys back in the day would be like putting it on wax, that meant you put it into the recorded. Yeah. Yes. It's unbelievable. But you got to go to the Thomas Edison Museum. You never been?
No, never been there before.
Okay, this is it. Here it is. It's in West Orange, New Jersey. It's totally worth it. Okay, so everything's there. So this is his house, and it's like up the block. But more impressive than that is the actual factory. Okay, now this is the crazy part. You see this?
Oh my God.
They stopped. He died in 1931, but they stopped in like the 50s. Let me tell you, it looks like everybody's on lunch and they're coming back. Like, it's crazy. They left oil marks, dirt, clothes. There's like tools are left out. Like, it literally looks like they're coming back after lunch. This is his recording studio. This is where all the Victrolas are. This was his chemistry lab. There's a statue of him. Here's his machine shop. So upstairs, they can make anything the size of a wristwatch, and downstairs, they can make anything the size of a locomotive. So he had everything, like an entire collection is there, like everything, every invention he's ever made. Early on stuff too. Anyway, cool. There's a rabbit hole right there. All right. Well, yeah, we're getting close to 10 o'clock. It was pretty good. I'm so excited for you. I think you're doing amazing stuff. Thanks for doing this. I know you're busy.
No worries. Yeah, thanks for bringing me out here. Honestly, it's like great what you guys are doing. Like all of you guys, like what you're doing with you and your students. This like podcast, absolutely amazing. I applaud you and like please continue doing this. Like, I don't know, we need more people like this. To be honest, like more teachers like you guys. Oh,
thanks a lot. Yeah, we're trying to recruit people all the time. There's a deficit. They don't have enough teachers. Not a lot of people go into this. Like, there's people that know how to build stuff, and there's people that know how to teach. And usually, it's pretty rare when you get both. But you're great because I think you've been teaching and sharing as you go. Which is really good. I think that you're kind of like a teacher and a doer, which is great. We kind of need that. So awesome. All right. Well, I'll let you go. This was good. And and so if they want to follow on your story, we got Riley the Riveter, not Riley the River, Riley the engineer now.
Yeah.
That was cool. But that was the kickstart right there. I can't believe that was a conversation we had like 4 or 5 years ago, or maybe more.
Literally right there. But yeah, like feel free for anyone who's like watching this, like message me if you have any questions about like engineering, what life is like at Brown. Honestly, anything. If I can't answer, I will find someone who can. Just here to be a resource,
Nice. I think that I will. I'll pass this on to a lot of the students, in the classes. I think that connecting the dots is huge. Like even just seeing someone from Memorial doing all this stuff like really helps, even if they don't catch all the details, but they will stay in touch or follow you on Instagram. Who knows, So thank you for doing all that. And it's great stuff. You got all these posts. What's going on here?
Oh, that's one of our track saws. So I was about to teach a workshop on that, on how to use that tool. One of my favorite tools.
Wow, no kidding. The fest tool is serious.
Oh yeah, it's awesome. It has a sander too with it. It's a whole the unit, you know?
Yeah. And I like the new cut.
Yes,
is
oh my
good.
God, big fan. Best decision.
Awesome. Awesome. All right, cool. This is great. Thank you for doing this, and we'll talk to you soon.
It was great talking to you guys.